everyone. Welcome to our webinar. Today we'll be talking about cybersecurity incident response and thinking about when a cybersecurity incident occurs, how will you respond? So for our webinar today, we will be using the GoToWebinar application. Please make sure your speaker is enabled in all places. And if you have any questions as we go through the presentation, there is a questions tool that you can use to enter them. There should be about 15 minutes left over at the end for questions, and I will plan to go through and answer all of them then. Before jumping into the material of the webinar, I like to just give a brief introduction on myself. My name is Patrick O'Brien, and I am a safety and cybersecurity engineer at Exida. My background is in chemical engineering, and so I started out more on the functional safety and process safety side, leading lots of HAZOP and LOPA studies. But over time, I started to transition and look at cybersecurity as well, because cybersecurity was becoming such an integral part of the risks to operating facilities. At Exida, we are a customer-focused company, and so we really work directly with our customers to achieve safe, secure, and reliable solutions. And there are three main ways in which we do that. The first are through our powerful lifecycle tools that really help to not only get the correct results for a lifecycle activity, but to also make sure that we can get there efficiently and clearly communicate those results. Our next group is our certification and assessment division, where we help manufacturers certify their products and different types of equipment to functional safety and cybersecurity standards, as well as a number of machine safety and automotive standards. And then lastly, our comprehensive lifecycle services are where we really work directly with facilities to try to solve the toughest, functional safety, security, and alarm management problems, and really tackle those tough issues. This presentation will have three main components. The first part will be looking at how do we initiate our emergency response plan. What is something that will trigger it, and how do we know when to start using it? From there, we'll look at the elements of an effective emergency response and think about what are the key steps that we need to take, what are the considerations, so that when we are replying to these emergency scenarios, that we understand what needs to be in place. And then lastly, we will look at testing the emergency response plans and make sure that when they are in place, that everyone has the ability to really get used to them and make sure that they are kind of comfortable with this steps for the response. And this will also give us opportunities to improve our response plan, which can help to make sure that we're continuing to improve and getting better over at time as we think about our response to cyber incidents. So for our first step for initiating the emergency response, we really want to make sure that we kind of retool our mindsets and get used to the fact that cybersecurity incidents aren't going to be a question of if, but they're really more of a question of when. And so a recent study showed that over half of industrial control systems experienced attacks between 2016 and 2017. And the follow-on studies from both 2018 and 2019 have showed similar results, with the number of control systems being exposed to attacks being right around that 50% mark. What we're also seeing in the current threat environment are that many automation systems are really wide open to cybersecurity threats, and that few of these organizations are really prepared to respond to cyber incidents. When we think about emergency preparedness, their response plans in terms of cybersecurity, and really understanding what the critical steps to take are. The last trend that we're seeing that can be part of the explanation for why more control systems are seeing attacks is that sophisticated tools are becoming more readily available to unskilled attackers, which increases the likelihood that a threat agent may have the capability to target a control system. If we think about effective means for really defending the control network from cyber attack and looking to improve the overall cybersecurity readiness, one method of doing that is looking at the IEC 62443 lifecycle that drives us through really assessing our cybersecurity risks, implementing adequate protections, and then really maintaining that security over time. And so for a lot of our webinars, we spend a lot of time discussing the assessment and implementation phase, but it's really the maintain phase that the control system is going to spend most of its life in. And so that's why for this series, we really are focusing in on that maintenance phase and thinking about how can we maintain security over time, and how can we respond to prevent the security incidents from leading to a major accident. And for our webinar last month, we really looked at monitoring cybersecurity and different means of identifying an attack. And so we'll start by looking at really the first part of the incident response and how that ties between our two presentations. For the incident response plan, it's comprised of both proactive and reactive measures. And so we can think of proactive measures as things that are going to help us prevent incidents in the first place, as well as making sure that we're more ready to respond to the next one. Whereas reactive measures help us to detect and manage the incident once it occurs to really limit the consequent severity. And so for our first step, when we think about initiating the incident response plan, it really covers that detection portion. And so without having a step to initiate the incident response, we would never really be able to put the response plan into practice. We would never be able to use it when needed for an emergency scenario. And so to really make sure that we are effective in initiating the response plan at the right times, there are a couple of key factors we can look at. The first is having a clear definition of what a cybersecurity incident is, and why the response plan would be implemented for it. The next one would be to think about, for our existing cybersecurity monitoring, are there tools or processes already in place that will help improve our detection of cybersecurity incidents and allow us to better understand which incidents should be escalated and identified as security concerns requiring a response. And then lastly, we can think about leveraging existing emergency response procedures for facilities to really make sure that cybersecurity becomes an integral component in that. If we think about our first step, defining a cybersecurity incident, it really comes down to the characteristics of, what should a cybersecurity incident look like? What are some different factors that we can say are indicative of that incident occurring? We want to be careful here. If we're too specific, so if we say it's, a given string of malware on a very specific, deployment or a very specific attack pattern, we may not be alerted to all of the security incidents because we're constantly on the lookout for that very specific definition, and it may not perfectly match, but it may have some elements of it. At the same time, if we're too broad in our definition, we may be alerted to every configuration change, whether it's approved or unapproved, or any time that there's a known vulnerability that might require a patch. And so by kind of trying to get that middle ground of having enough criteria without making it overly onerous to identify an incident, we can hope to make sure that we're capturing the right ones in the response plan. Another consideration is thinking about who or what roles have the ability to decide, if something is or isn't an incident. And so sometimes the best way to answer both of these questions is to use escalation effectively. So we can think about, if an operator in the control system notices some sort of cybersecurity anomaly, it's taking much longer to load the faceplates today than yesterday, that may be a clue that we are experiencing an incident, or it may be another, some sort of activity going on the network. But if we make them comfortable to approach, the operations supervisor or the OT supervisor and outline what they're seeing, we can then start to bring information in front of the key roles for deciding if it's an incident or not. And that'll really help to, make sure that the more critical events are identified and then escalated appropriately. We can also think about how our cybersecurity monitoring solutions can help us, tell the difference between some sort of normal network occurrence or a network anomaly, and whether or not that anomaly represents a potential cyber incident. We can think about our intrusion detection systems or other cybersecurity alarms as really a direct measure for indicating scenarios that may need a response, and may have associated, troubleshooting or steps, directly associated with them, that may lead to initiating the response plan. We can also think about leveraging our baselines of the control system of the network, to really have a more clear picture of if something is a deviation from normal or not, which will also improve our ability to identify concerns. And then lastly, as we talked about last month, security operations centers, or a centralized unit within the organization for identifying and responding to incidents, is another growing trend we're seeing in cybersecurity. And so for anywhere that is implementing a SOC, they typically will have personnel specialized in incident detection, who may be good resources for either reviewing if network activity is indicative of an incident, or may be the first to identify an incident and alert the local facility. The last thing that we want to think about for initiating and really starting the emergency response procedure is leveraging our existing processes. And so I say nearly all, but I really do hope that it's just simply all operational facilities have some sort of existing processes in place for responding to reasonably foreseeable, undesirable scenarios or disaster scenarios, whether it is, severe weather, loss of power or utilities, or one that, has often been included on the list, and I think certainly after the current situation, will be added to nearly every emergency response procedure, is also thinking about a pandemic where there's a limited ability to be on site at the facility. And so really, cybersecurity is more of an extension of these scenarios and doesn't need to be looked at as, starting from ground zero or reinventing the wheel. We really want to make sure that cybersecurity incidents are now added to these as another potential scenario that needs to be prepared for. And so by taking advantage of policies that are already in place, we can typically get a more effective and faster implementation of the cyber response. And that can either be as a part of the existing policies, directly as adding a new section, or it could be a new document, but still reference back to and have clear ties to the existing policies. The next step that we're going to think about is, for an emergency response to be effective, what are the key criteria? What are the steps that need to be put into place? And so if we go back to kind of our overall definition of the incident response plan, we're now thinking about still reactive measures, but how can we contain, remediate, and restore the system following the cybersecurity incident? And so to do that effectively, there are a couple of key items to be included in the response plan. The first is to have a clear definition of the incident manager, really that one central person who's going to be leading the response. Setting up clear communication both internally and externally can be another important step to really make sure that the organization is responding fluidly throughout the event. We want to think about what are the key response goals, what are the steps that we need to achieve, and what sort of priority does each of them have. We can think about what are the critical technology areas that support the control system processes, and think about how are we going to be able to restore those effectively. And then lastly, we want to think about, for the long term, what are the business continuity impacts of the incident, and how can we take that into consideration to really limit the overall damage to the organization. And so a lot of times business continuity is looked at as a separate but related part of incident response, and so it may have its own specific procedures depending on the organization. But for this presentation, we're going to look at kind of a high-level summary of that and how it plays into the rest of the incident response. So for our first step, we want to have a clear definition of the incident manager. For an operating facility, oftentimes this could be the plant manager or another member of the senior management team, whether it's the OT supervisor or control supervisor, someone who is familiar and has knowledge about the automation system. An important thing to note about the incident manager is that it doesn't necessarily need to be one person for all of the different incidents. So if there are certain disaster or weather scenarios where it makes sense to have the plant manager be in charge, it may still make sense to have the OT supervisor in charge for cyber incidents. So it doesn't matter so much about the specific role, but the key things that need to be looked at are, do they have the authority to make decisions about their response and make decisions about the steps that are going to be taken? And do they have the authority to allow others to complete necessary response tasks? What we're hoping to avoid here is kind of every step of the way having a chain of 5 or more people really looking at an action and making sure that there's agreement to go forward on it. We want to be making decisions effectively and responding as quickly as possible. In support of that, there are a couple of best practices that really can help to improve the internal communication during the response. So one of the first is to establish a war room, or really a central point for coordinating the response and making sure that everyone is on the same page and taking the necessary steps. We also want to think about, for remote personnel, is there a way to give them virtual access to the war room, whether it's a video conferencing software or even just a phone line, to make sure that all of the different parties that are working together can stay on the same page. After the initial meeting in the war room and really giving the first round of tasks, it typically is beneficial to hold periodic update meetings as opposed to kind of having the team be fully freeform. And the reason for that is it really lets the team members have mobility to split up and work on different objectives, knowing when the next report in will be and when they should report back to get updates. And then the last best practice is to make sure that there's one defined point of communication between internal stakeholders. And so really to limit the number of different stories being told, to limit any potential misinformation, we want to be rolling out updates to corporate management and other sites at defined time periods and with information that has been reviewed and everyone is comfortable with, really to try and limit the amount of confusion that's going on. If we think about for our external communication, we really do want to follow similar steps in having clearly defined personnel or roles who will be handling that external communication, as well as considering who are those external stakeholders that will need to be informed. A lot of times control systems are going to have impacts on upstream or downstream processes, whether it is a downstream user or a customer from the site, or if there are suppliers or different units that are responsible for feeding the site, as well as other production sites in similar environments that may also be affected by the incident. In addition to thinking about the direct stakeholder relations, it's often also a good idea to determine regulatory agents and make sure that the correct ones are contacted and informed of the type of event that's occurring. This can help both with really tracking data on different types of threats, as well as taking advantage of existing resources for responding to attacks and incidents. The next step after establishing the proper lines of communication is to really make sure that the safety of plant personnel can be maintained. For operating environments for control networks, it's really different in terms of possible consequences from a strictly IT aspect, because it's not just business impact, it's not just money. There are potential safety concerns as well if key plant processes are down. So our first goal always is going to be ensuring the safety of plant personnel. From there, we can think about what can be done to minimize the operational disruption. What are the key steps for maintaining data for forensics? What are our different functions that need to be restored? What are the essential processes? And so thinking about what are the different technology that need to be in place for those processes. Um, we'll also want to think about how quickly and in what time frame should they be restored. Thinking about, are there systems that need to be brought up first? Do we have backups in place? And really setting realistic timeframes for what can be done to recover from the incident. If we think about the initial response, so our first set of goals is always going to be to isolate the compromised assets. And so if in our example control system, if we had a compromise on our DMZ, the first step is going to be block the affected asset and also limit the communication into the DMZ zone, both from the control system and from the enterprise workstation, to really make sure that we aren't spreading the virus or the malware, or to limit the ability of the attacker to move to another system. During this process, we want to make sure that we are maintaining data for the isolated equipment for analysis, as this is going to help us with our post-incident forensics. After we go through and isolate the immediately identified assets, we really want to try to understand the extent of the compromise. So we want to review any connected devices and see if the malware has also affected them as well as looking at adjacent systems to understand, was the attack able to jump through any zones? Are there other areas that need to be isolated as well? And so by going through and doing this, that should give us information to answer the question, can the plant be operated safely, to really maintain our number one overall goal. And so then from there, kind of the transition from the initial response to the, say middle phase of the response is then thinking about what actions can we take to restore critical processes. And so while we don't want to go overly specific in the response plan with specific step-by-step instructions for how to restore a communication failure on the control system network, we do want to think about what are the technology areas that support essential control system functions, and what sort of high-level guidance can we define that will be useful for a variety of scenarios and help us to restore them in a really as fast a time as necessary. And so for some common technology areas in the ICS, we can think about a basic process control system or a distributed control system. We can look at a supervisory control and data acquisition network, the safety system, different communication means, and also power and other critical utilities. And really think about, if any one of those were lost, what is the best way to restore access? What are those key steps? And so some ideas of how we can do this at a high level where it will be useful for different events, without getting weighed down in the specifics. There are kind of some higher level or general methods for restoring processes. The first would be to do a restore from a backup file. And so nearly all control systems will periodically take backups. And so thinking about trying to restore the configuration from the last time a backup was taken. Now, something to be considered for this is that some attackers who are more sophisticated really wait to corrupt a number of backups before they actually execute the attack. And so before reloading from a backup file, we do want to go through a test process to make sure that the backup hasn't been affected as well, to really make sure that we aren't just getting back to square one. The next means that we could look at is having redundancy or hot standby systems. And so for controllers, we can think about a hot swap over controller. It's typically more common to look at for servers or virtual machine monitors. But thinking about if there was an OSI Pi server or a DataTrend server that was being used, if that initial one failed, oftentimes in the DMZ there will be a secondary server that will automatically take over and continue the process. Another means is looking at high availability systems. So thinking about for our controllers, uninterruptible power supplies as an example, that even in the event of the incident or of a loss of power security event, we still have power to those critical systems so that they can maintain their availability. If we think about using an alternate system, this is now looking at another means to implement a service or to, cover an objective without explicitly correcting the part that was affected by an attack. And so if we think about communication services as an example, if we had something that resulted in a loss of voice over IP in a facility, instead of maybe needing to restore that, if we switch to cell phone communication, we would be able to restore that process of communication, but we would have done it without the specific system that's affected. We can also look at function reassignment, but this is typically more applicable to enterprise and control environments because it really requires switching a critical process off of the main device onto a less critical device to take advantage of any extra storage or capacity on that device. And so while that is something that can be done for servers, it's not something that's really credible or feasible to do for a controller or something on the control network. And so if we think about shifting from our medium-term response of really trying to restore given services or technology areas, our long-term response is really where we come into the idea of business continuity. We want to think about the business impacts of the incident and really use that to make sure that we are having the best goals for responding to the incident, that we are maintaining the health of the team and the organization throughout the incident by really understanding what the appropriate time frame to respond is. And so typical questions for a business continuity plan would be thinking about how long can a company survive if a given asset is affected. Thinking about the different roles and areas of the organization that need to respond, and really helping to drive that response time frame based on the business impacts. Thinking about, are there any alternate facilities or different means that could be used to limit the impact of downtime for a facility, and then thinking about what from a business standpoint needs to be restored first, and how quickly does it need to be restored to really maintain the viability of the organization. So one example that we can look at for incident response is the Ukrainian power grid case study. And so in 2015, part of the Ukraine power grid was shut down for several hours, resulting in lost power for hundreds of thousands of customers. And so we saw that attackers were able to gain access to the corporate network through a targeted phishing campaign at system admins. There was a harvesting of remote login data, and so they were actually able to get in through a VPN and compromise the SCADA. And so at the facility, the operators could actually see the attackers moving the mouse around on the screen, and for as long as they could, really tried to manually disrupt the attackers, but ultimately were stopped when the local keyboard was disabled. And so we can see, even in that initial response, they are taking steps to try to limit the success of the attackers, and try to prevent the incident from occurring. We also saw that the attackers overwrote the firmware for critical devices, and so that even after power was back on and the incident had been isolated, there was still no way to operate the breakers using the control system. And so what moved into more of the long-term response, or the business continuity, was that retired or former employees were brought back to the site because they had knowledge to operate the power substations manually. And so for this aspect, we can think that more like an alternate function, instead of controlling or returning the automatic function, we saw that they were able to really move to a different means of control and actually restore operations that way. what we can see also is that then is going to impact, how long the facility is disrupted and how long the power was disrupted. Another incident response case study that's not directly related to cyber, but I think has the opportunity for some good, correlations is actually a recent case study from my own life in which my apartment flooded. And so the cause was heavier than usual rain that resulted in my basement window filling with water and then beginning to leak through. So in terms of communication, I had to talk with both, my internal stakeholders, my roommates, as well as with the landlord to communicate what the best actions to take to prevent the leak from continuing and look at, minimizing the impact from the flood. And so, my initial goals were to stop any more water from entering, prevent damage to my possessions in the room, and then to remove the water and restore the room back to its normal clean state. Some of the supporting technology areas that I needed to do this, were towels, buckets, a wet vacuum, and then a dehumidifier for getting rid of residual moisture. And so by having these different areas in place, I was able to respond and really limit the damage that the flooding caused. And luckily, I was very fortunate that I didn't end up losing any possessions from it. If we think about testing and improving the response plans, there's always areas to do better in the future and think about really having that more proactive approach. And so even for my example, there are certainly things that I would have done differently if it flooded again. And so really trying to improve and respond more quickly the next time. And so for the proactive portion of the incident response plan, we're going to start with the post-incident analysis and then really see how that feeds into the planning as well as incident prevention. And so for our post-incident analysis, we want to really analyze the attack so we can characterize the type of attack. We can think about the type of threat agents who may be able to deploy it. We can also look at what specific attack mechanisms were used, trying to understand what parts of the network were compromised and what features or vulnerabilities led to that compromise. And really what that'll allow us to do is plan for the future and improve cybersecurity defenses to prevent another similar attack. And so during this post-incident analysis, there are a number of different techniques that can be used. We can look at security and event logs to try to get a clear timeline of what assets were compromised at what time and really follow the access logs in that way. We can look at doing a disk and file analysis, so making a disk image of a compromised workstation or server to really try to get more information from that. We can really look at the RAM of a device to see what code is being executed on it. Or we could use for our network traffic analysis, we can use some of those different monitoring tools that we discussed in our last webinar, really to look at the traffic and analyze what was occurring during the incident. One thing that is good to note is that attackers have continued to become more sophisticated in the means with which they try to really cover their trail or hide the traces of the attack. And so sometimes it can be beneficial to bring in forensic specialists to really support this activity and make sure that a good characterization of the attack is completed. If we think about now testing our incident response plan, if we never test the plan, how will we have confidence that it'll work when we need it? We really need to be able to understand and be comfortable with the plan before we can deploy it. And so there are a couple of common means for testing the plan. The first would be to do tabletop exercises. And so thinking about doing some different example scenarios. We can also talk about drills and testing out specific parts of the response plan to see whether or not they would work in practice. And we can also do periodic training on the plan that may include one or both of those elements to make sure that everyone with responsibilities in the response plan are aware of it and are able to respond and really meet their responsibilities if needed. If we think about testing the response plan in more detail, for our tabletop exercise, we are really going to go walk through and look at an example disaster scenario with all of those key stakeholders that we expect to really need to respond to the incident. And so some best practices here are to really plan the incident ahead of time, have a scenario that has some detailed information and have a leader of the exercise so that when people are starting to think through it and respond, they can kind of ask them what if questions and talk about, what if we move to this subsystem, or what if we took this action to stop the attacker? And so that can be really beneficial to get the most out of the exercise. Another important thing is that for the test, we want to make sure that we have a low stress environment that everyone is comfortable participating in, really to get an idea of what parts of the procedure work well and what are areas for improvement where we can improve the plan for the future and make it so that we are better able to respond to an incident. For the drills, kind of separate from the tabletop exercise, they're typically much more limited in scope, but they're good for getting more detailed information about key steps of the plan. So if there was any sort of evacuation part of the plan, or if there are parts of the plan that a broader group needs to implement, that can be where it is beneficial to do more of a periodic drill and gain some information about how effective that step of the plan is. If we think about then taking this and improving the incident response plan, we really want to make sure that we are grabbing the lessons learned to really have that continuous improvement in place. And so those can be results from test activities and what we've learned from practicing the plan, as well as the results from real world incidents and what we've learned from previous cybersecurity scenarios. And really, in either case, the best practice for improving the plan is to make sure that there are clear notes, both on each of the tests of the response plan, as well as clear event logs that will support really documentation and improvement in the future. And then lastly, kind of as we talked about, we want to think about what can be done not only to improve the response plan, but also to improve our readiness and our ability to respond as a whole. Even in terms of network segmentation or other security countermeasures that would improve the protections of the system. And so as I was going through and preparing for this presentation yesterday, I actually had another experience where my room started to flood. We had, some increased rain from the tropical storm Isaiah, and it, started to very quickly fill up the window well again. And so luckily this time I was more prepared and had implemented a number of improvements from the last time the flooding occurred. And so the first improvement was what I called my rain catcher system. And so essentially setting up towels to really direct the water and funnel it into a bucket for collection. And what I had seen was originally, the first time it occurred, it was very difficult to kind of capture the water coming over the windowsill cleanly, and much of it was running down the wall and getting trapped on the floor before it would actually go into any sort of container. And so by working on the design, I was able to more clearly funnel the water, and I actually was able to catch about 1.5 buckets worth that otherwise would have been coming into my room. Some other steps that I took since last time was I had a higher number of towels, which could help me, not only direct the water more effectively, but actually dry up anything that got wet as a result. And then lastly, I was able to move the furniture out of the way more effectively this time because I'd already walked through and done the exercise once. And so it really kind of helped me to respond more quickly. It wasn't perfect this time around, but I certainly prevented much more water than last time from getting into the room. and overall was able to get my room back in shape for much less time than it took the first time around. But it's not to say that the process is done, and I certainly have some ideas of how I might tweak the system to make it a little bit better in the future. And so if we think about that and some simplified case studies, we really looked at the 3 different parts of the response plan. So first, the steps for initiating the emergency response plan and making sure that we can put it into place. Then looking at what are the elements of an effective response, and lastly, how we can test and improve our response plans over time to make sure that we are continuing to improve. And so now I'm going to kind of just run through our outro slides. If you do have any questions that have not been put in yet, this is often a good time to ask them. So, as we continue to go through these difficult times, Exida is staying committed to really supporting all of our customers' need. And we've done that through improved remote meetings, remote certification processes, and also enhanced online training and personnel certification options to really make sure that we're able to give as comprehensive of an experience as possible remotely with limited travel. And with that, we've also increased the number of online training courses that we are being offering. And we have a number of those listed here that can also be found on the Exida Academy website. In addition to our scheduled courses, the one that I do want to just highlight that's coming up is at the end of September, I will be teaching the CS 102 Automation Cybersecurity Lifecycle class, which really goes more into all of those key steps of the 62443 lifecycle that we looked at. In addition to these, we do have online self-paced trainings, including the CS 102 course. And so if you are interested in learning more or getting updates about similar webinars in the future, don't hesitate to follow Exida on our social media and receive those updates. And so now what I will do is I'll go through and start to answer some of those questions that have come in. So the first question I see here is, how does the incident response plan for OT or industrial control system cybersecurity differ from that on the IT side? And so I think, on some levels, they are similar in terms of thinking about, what can be done to restore key processes and thinking about different network reliabilities or backup aspects. Those are going to be similar between the IT and OT sides. What's different is really the potential impact of the incidents. And so while an IT response is primarily concerned about a data breach or some sort of loss of availability and financial impact, a cybersecurity incident can have a very significant health and safety impact, or have actual equipment damage or different things like that. So the response plan for the OT side, really has to consider the physical system and the potential hazards associated with that to make sure that we're responding in the best way and maintaining the safety of everyone involved. So the next question here is, do you recommend an integrated incident response plan to address security and safety, for related incidents? And so, yes, I think you certainly want to have coordination between the 2 plans. For me personally, it doesn't matter as much whether they are one single plan or 2 separate plans that are related. I think sometimes just having one plan can be the cleanest, but if you already have an existing EHS procedure and it's difficult to, get the cyber piece added in, there's nothing wrong with having a separate cybersecurity procedure and just making sure that it references back to the EH&S procedure. So certainly they want to have a coordinated approach, but whether or not they're integrated into one document, I think there's some flexibility on that. Okay, the next question here is, typically the control networks, thinking about level 1 and level 2, will be connected to the business network through a dedicated firewall. would an effective disaster plan be to kill the power of the switch? And so I think depending on the incident or the type of scenario, that could be an important first step. And so if the response that we are responding to is a compromise on the um, control system itself, that may not be as effective as if we do see a compromise on the um, enterprise network and are worried about it, leaking into the control system. So certainly in terms of isolating the business network from the control network, killing the power to that firewall or blocking the communication through it is going to get us there. If we think about an attack that already has access to the control system, it may still be good to stop that to prevent it from spreading, but it doesn't necessarily mean that we're done if we just shut off that one point of communication. We really need to investigate and understand what has been changed on the system, and are there still different ways that the attackers may have access. So then the next question is, testing response plan during running plant can be risky. Is it okay to test on a demo system with samples and then validate the results? So yes, I would certainly agree that you likely aren't going to be wanting to test backups or different modifications to the network on the live control system, because that could have a potential negative impact on availability. So I would certainly agree that it is not only okay, but actually recommended to use a demo system and really look at what are the results for that and see if it can be applied to the overall system. And so I've seen some customers with actually some pretty creative solutions to this who have had kind of mobile workstations that they could use to deploy to multiple different areas in the SCADA network. And so they would typically work with that test platform and then a test environment to show that it was able to work and that they were able to log in and gain connectivity that way. But do certainly agree that we don't want to have a test on a live network that is going to potentially disrupt operations or have a similar impact. All right, so looking through, that is the last question that I see. If you do have any other questions, please don't hesitate to send me an email at pobrien@exa.com. I'm certainly happy to get back to you on that. And do always like the discussions following the webinars. Again, thank you very much for joining. My name is Patrick O'Brien, and I hope you all have a great rest of your day.